Good morning, everyone. This will be your pre-lab lecture for today's lab. Before I get started with that, I do have a couple announcements to make. Make sure you are aware that you have your midterm exam on Tuesday for your lab. It will be administered through LabFlow. So make sure you're over there. Um, the big thing to know about this is that it will open at 8 o'clock in the morning on Tuesday, right? Like a normal lab, but it will close by the end of the day, because for exams you only have the day to take the exam. So you have from 8 o'clock in the morning to 11:59 p.m. to take your midterm exam. Make sure you take it. Do not wait until the next day. It's absolutely due by the end of the day on Tuesday. Many of you may be wondering, how do you study for the midterm exam? If you go through LabFlow to your previous quizzes, you can actually go. There's a little button where you hit the review button for your previous quiz, and then it will show you the questions, your answer, and the correct answer for each of the quizzes. And then the other way to study for the exam is to look at your reports, the PDF, the PDF that's provided to you to actually do the lab, and then your actual submitted report, which is also available too for you to study. So that's how I would study for the midterm exam. Once again, just a reminder, it is this Tuesday, and it is due by the end of the day. Do not wait until the next day. It is due by the end of the day, unlike normal labs. Okay. Let's see here. So today's lab that you're working on today, virtually, is called the extraction of caffeine. And what you're going to be doing is you're going to be extracting caffeine virtually from Vivarium tablets, which I think are pep pills or something like that, or caffeine tablets. I've never actually ever seen a Vivarium tablet in my life, or a caffeine tablet for that matter. But spoiler alert, there is more than just caffeine in caffeine tablets, right? So when you extract caffeine, you're going to use a couple different methods. One of them I already alluded to in a previous pre-lab lecture, which was using a separatory funnel. Excuse me. And then the second one will be the drying of the organic layer with a drying agent, right? So let's just go ahead and get started here real quick. This won't be a very long pre-lab lecture. You have a separatory funnel, remember, that looks like a pear. Maybe even a little heart, I don't know. And then at the bottom of the separatory funnel is this little pipe, right? And then in the pipe is a little knob like this. This knob is known as a stopcock, right? And what it can do is that it can turn to allow you to open up the pipe or close the pipe so things can flow through it, right? And then at the top here, there's usually a glass stopper, okay? So when you're doing a reaction, and you end up with like a mixture of stuff, right? Like your reactants, your product, and all this other stuff, the solvent that it came into, right? You've got to do something to actually clean it up, get rid of all the stuff in there, other than your products, right? And generally, you'll start out by washing it with water to get rid of all of the inorganic kind of like polar stuff that's not your that's soluble in water, that's not your product, right? So generally when you have a separatory funnel, you'll add in your water, right, to an organic layer, right? And the organic layer, depending on what the solvent is, that's your organic solvent that you're using, your organic layer is. Most organic solvents are actually less dense than water, so they'll end up at the top, right? So we call that the organic phase. And then the water ends up at the bottom, right? And of course you pour it all in to the top, right? And this is the aqueous phase. That's the phase that that you have water. And again, the water will actually wash the organic solvent that you were using, the entire mixture of all of your products and your reactants and all that stuff mixing. It will wash it of all the things that are soluble in water, right? So what you do is that you're pouring the organic solvent first, right? And then you can wash it with water by adding water to it. And since these things are immiscible, right, they should separate immediately. And the more dense thing will be at the bottom, and the less dense thing will be at the top. And in most cases, the organic layer is less dense, so it will be at the top, right? And so what you do now is you take the flask, not the flask, sorry, you take the funnel, right, and make sure both sides are stop cocked, right? Make sure the stopper's at the top and the stop cock is closed at the bottom. You flip it upside down, you point it away from your friends, right, because you don't want it to shoot at your friends, and you shake it, right? You swirl it around, not vigorously, but you shake it so that the water literally goes in and washes the organic solvent, right? You do that, and you can flip it back again so it's right side up this way right here. This is right side up, right? And then the layers separate again, and then all the inorganic and the polar stuff that wasn't your product will move and get cleaned out of the organic solvent and move to the aqueous layer, right, or the water, because it's more soluble in water than it is in the organic phase. Than it is in organic phase, right? And so what you do now is this could be a multiple step process, right? But what you do now is you can turn this knob, right, so that you open up the pipe, and then you can very slowly drain out the water, right, into a flask sitting below it. That's a terrible looking flask, but that's my flask, okay? There we go. That looks better. That's a flask, right? And so the aqueous phase goes down here, leaving you behind with just your organic phase that's at the top, right? So you close it right before it gets to the organic phase, or when it gets to the organic phase. So I was saying that this is a multi-step process because you need to wash it with the water multiple times, right? The aqueous phase multiple times. So you just keep on doing it until you feel like you're good, okay? And so we need to talk a little bit about how this works as far as chemistry goes. So imagine then that your product is something like this, right? A carboxylic acid, right? Right now it's protonated, so it's neutrally charged, right? It's it has no charge, right? No charge on it. And what you can do, because since it's like that, you know that your product here is soluble in organic, right? It's soluble in the organic layer, or in the organic solvents, right? So say you want to actually remove it from the organic layer and move it to the water layer, you could treat it with some base, right? Or we don't say treat, we say extract. Extract it with some base, right? Extract with base right here. And so that's when you have up here your organic layer with that molecule, right? And then the bottom layer is water with some base in it, right? Like sodium hydroxide or something, right? And what it can do is it can deprotonate that proton there, making your product now, instead of being a carboxylic acid, it's a carboxylate ion. And when it's a carboxylate ion, it's much more soluble in water. Soluble in water, right? And so it moves down to the aqueous layer, right? It moves down to the aqueous layer. So now you've moved it away from all the other organic impurities that are in the organic phase into the water now, right? Now this is after you've already washed it before, and you have clean water in there now, right? And base. And so once you have it there and nice and clean in the water, you can put it back into the separatory funnel, right? And then extract it again with some acid. And when you added the acid in, right, you can protonate your carboxylate, and you end up with your original, man, I am having a problem drawing today. You have your original carboxylic acid, right? Which is now soluble in the organic again. It's soluble in the organic phase again, okay? And so now it moves from the water, right, phase into the organic phase, which is at the top. So at that point, you can drain out the water at the bottom, knowing that your product is now back in the organic phase, and you can keep the organic phase, right? And that organic phase conceivably should be mostly your product and just the organic solvent, right? Just the organic solvent, a new organic solvent, one that's not the one that's your that was your reaction was in, like a clean one, okay? So the problem though is that when you do this, right, there'll still be traces of water left over that are from that aqueous phase in the organic phase. So you have to get rid of that water somehow, and this is when you bring in a drying agent. I don't know why I have to write out the word bring in. I was going to write out drying agent, but I committed to bring, so I have to write it in. Drying agent. And then there are a few drying agents that you should be aware of that can remove water. The most common one that we use in organic chemistry is mag sulfate or magnesium sulfate, right? It's anhydrous, so it doesn't have any water in it, right? But when it encounters water, it becomes hydrated, right? And that's why it can be used as a drying agent. Another one is calcium chloride. The difference between calcium chloride and magnesium sulfate is that magnesium sulfate is like a very fine powder, and then calcium chloride is like little beads, you know. So one is super easy to remove. So one is a powder, so you have to filter it, right? One reacts with protic solvents more than they do with non-protic solvents. So you pick the one that is appropriate for your solution, for your experiment. There's also like commercially available things too, like Dry-Rite. It actually is like a blue powder, like blue chips, and like when it encounters water, it actually turns pink. So that's kind of neat. But the problem is that dye that turns color does react with organic solvents, so it doesn't really work well in an organic reaction where you're trying to keep things. Excuse me, sorry, I had to stretch there. When you're trying to keep things clean. So mostly Dry-Rite is used to like keep things dry inside of a desiccator. And then there's also things called molecular sieves. Molecular sieves are literally tiny little balls that have pores in them, and the pores are the right size to capture water. So those work too. I've seen a lot of people use molecular sieves. Sieves are used a lot in like what is it called? Water purification systems and stuff like that. Like when you're trying to make your hard water soft, right? And water in Arlington here, where I live, is pretty hard. So maybe I should get some molecular sieves. Anyway, so you captured your organic layer, right, inside the flask. Man, I'm really bad at drawing. I used to be really good at drawing flasks. I don't know why I'm so bad at it now. Maybe it's because it's digital. Drawing on paper is easier. So you collected your clean organic layer, right, from the separatory funnel. It's right there, organic layer. Organic layer, which is where your product is. And you put in some, I'm going to say magnesium sulfate, right, MgSO4, right, and it goes into the organic layer, right. And what you do is you take the flask and you swirl it around, right, a little bit, where so that your solvent is in like the corner of the flask, and it's like swirling around in the corner of the flask, along with the magnesium sulfate. And if you see the magnesium sulfate clump up, it means that you're not done yet, right? You didn't put enough in there, and it's clumping up, and it's becoming really hydrated. So you add a little bit more. You stir it up. You swirl it up some more, and you keep on going until the magnesium sulfate looks like it's a fine powder, and that's when you know you're done. And then after you do that, you've got to take it over to a funnel with a piece of filter paper in it, right? You pour it all from the flask into the filter, the funnel, right? The funnel is sitting inside of another flask. We use a lot of flasks, right? So now the magnesium sulfate stays in the filter, and then your liquid, where your product is, stays in the organic phase, goes straight through the funnel and with the filter paper and goes into the next flask. Guess what the next step after that is? You've already done it before. You recrystallize. Yes, exactly. Good job. I know you guys were saying the answer while you were watching this, okay? So you recrystallize that thing, and then that's how you get your product back. So it's basically how this experiment works. Go through, do your pre-lab quiz, watch your videos. The videos are actually super good. I'm actually very impressed with LabFlow and their videos. And so watch those videos. They explain it really well, and you might even get it better from them than me because you're actually seeing the exact glassware they're using instead of my terrible drawings. And then read the PDF file, and then request your data from the report submissions thing, and just have at it. Right? This lab is due tomorrow by the end of the day. But just remember though that your lab final on Tuesday is not due the next day at the end of the day. It is due the same day. Okay? Just a reminder. All right. I'll see you in lecture, or maybe it's another quiz solutions video. I don't know. Good luck.